Today we are going to talk about how to create our polygons, because points and lines, which is especially this in the geography point and line string, we have already covered. So in the yesterday class we have seen some methods also, like st as text. So if you talk about this method st as text, so this is basically it is in the our select clause. So select clause means to read. So basically we are trying to read the geometry. So these geometry ID and name, these are our column names, and the column names we are using, we want to see this geometry which is a hexadecimal, which when you see it, so it will be a hexadecimal number. This hexadecimal number, it will be converted to a normal text, and we are calling it as geometry. So this is aliases. Aliases means whatever it is this function is doing, and it is putting. So in the column name, put the column as geometry, and this is from this from is could give taking the data a base name, or not database name, it is taking your basically your table name, correct? And we have used one where clause, so just for a condition that we don't want all the data, I only want the data for line string 3. So to reduce the data, we can also use this clauses, whatever it is. You can use limit and all. You can apply all whatever the functions you have learned in your Postgres, limiting and all others you can use here. So basically today we are going to create a polygon data, okay, and we will add some data inside that and we will see. So let's create a polygon inside our database. So I will go to my database. So this is my GIS batch 2 database, and we have the schemas. So schema, schema is a container which will be consisting of all the functions, all your tables, all your requirements that will be used to create your that will be consisting of the database. Everything is stored in your schemas. A schema is like a structure, okay. So you can see that we have created 8 tables now. So these geo lines, geo points and geo polygons are some points on the plane, and these real line string, the real points, these are our basically points on the on our real earth, and it is a spherical coordinate system we are using. So we will going to select the G2 beta GIS B2 database, and I is going to open a query tool. I will write a query here. So the query is to create a table of real polygons. So the your query is the simple. You use create table, and create table, this is used to create a table, and then you are giving the name of the column, name of the your table, okay, create table and name of the table, and inside the table you use a parenthesis to define the parameters of the table. So when you create a table, you give its column. The column which you use in your Excel is like a normal column. So here we can customize the column things, like what data type it should consist, and how much data it should consume, how much memory it should consume, what data type it will be. So all those things we can do here. So we are doing the customization. ID is a serial. It means we don't have to provide its number. It will be automatically incremented for each of the record, and we are calling it as a primary key. Whenever I want to call some data, I will call using this ID. And then we have the name. Then we have the, which is var character, variable character. It means it will adjust his memory shape, memory location, or memory size. Basically it's more towards the optimization of a database. Then we have a description of that data which we are going to add, and that is also var character. And I'm using a one more column, that is a geometry column, and this geometry column I am saying data type will be geography, and especially in the geography we will be having a polygon and a projection system 4326. So we have defined everything here, and now we are going to create a, now we have to insert the data inside this. So first you create the table. So you see the table is created here, and you can also refresh here to get it. So real polygon is here. Now we have to add some data inside this. So For inserting, we will use insert into what? Insert into real polygons. Okay, then we will give the values. Insert into, okay, just look into. So in the this table you have to give your column name, and inside the values you can give the polygon details. So let's add this data. So I have a very long data here because this is a polygon. We have to create a polygon. So first our data we are saying to insert into real polygons with the name, description and geometries, and values will be your polygon 1. It will be the name. Your description is like Central Park in New York, and it is using ST geography from text. So it will create a geography from the text. So text we are giving polygon, and in the polygon we have our pairs of lat long, longitude and latitude. So this will be a 1 point, okay, and this will be a second point, third point, fourth point and fifth point. So this polygon is consisting of 5 points, and those all 5 points are connected together. So when you connect, so the first point and the last point should be the same, then only you can connect it. Second point we are going to add with name polygon 2, and its description like it's a Hyde Park in London. Okay, this is in London, and this is ST geography from text. We are giving it's a polygon from text, it's a polygon and these are its locations, latitude and longitude values. So you can see that first point and last point is the same, so that it should be connected. Same way we have a lot of basically 5 polygons we have, and we are going to insert it into this polygon. Let's execute it. So successfully it is executed. Now I want to see the data what I have added. Okay, so we can see it using select star from I will not write, I will copy paste. From which table? From real, and just terminate it. Okay, semicolon to end my statement, and we will click OK. So I got correct. I got all the details, polygon 1, polygon 2 up to 5. ID is also there, which is automatically coming, and this is the lat long values in hexacode. Hexacode is from 0 to 9 and A to A B C D E F 0 to 9. Hexacode you can see there will be 16 things hexacode. Hexacode digits. So this hexacode is from 0 to 9 and A to F. So you look here, if you look here, there is nothing more than F. You don't find any data which is other than F. So up to only F it will be having. Okay, hexacode. Now I wanted to see all the data. I am selecting all the data and just clicking here. Just hope that it should be visible. Yeah, it is visible, but yeah, this is 1 point. Think yeah, 1 polygon is here. Yeah, see, 1 polygon I have created here. I don't know which polygon is this, so when I click here, so I know this is a ID number 5. So when I go to this data point, ID number 5 is a Tahir Square in Cario. So geometry, it is in a Cario. See this one. For more data we have to look into it very carefully, then only you will get it, because this is a very small polygon and we cannot zoom the zoom level here. Problem is that even I got it here. Yeah, one is here and one is here also. So we looked here in the Cairo. We will look here also. 1 point is here in China. Yeah, we have created 1 polygon here also. If you look, click here, so this is the 4th polygon in Tokyo. This is in Japan. With this all, how many points are 1, 2, 3 and 4? You can see this 4th, this one Tokyo data. We are giving 5 points. 1 point is this one, second point, third point, fourth point and fifth point. So fifth point is the only overlapping point, then it will be connected only. Okay, so we have created our data. If you want to export this data also, you can export. I will tell you how you can export these datasets, like we have created from here, but we can export it in our QGIS. So you can directly export it also, and you can use the PostGIS bundle. So let's go to QGIS and let's see how we can call the data. Data can be called also, it can be exported using the PostGIS. To go to PostGIS bundle, so you have to first do the connection here to connect with your database, and database name is GIS and B2, correct. I will say connect to my database, and connection is succeeded here. Now I will not go to import, I will go to export, and export add a table. So you can see that here we have all these points, correct. Real polygons we have. I will say okay, and I will say export it. I wanted to export these real points polygons, and I will say add data is done. Now you will say this export. So when you click on this export, it will ask for where you want to export. So I'm exporting here in this folder, E folder, okay, directly in the E passport. Say open, and see here, exporting with configuration, real polygons, public real polygons, and output save file polygon, table exported, completed. So let's go to our data, our E drive, and check it is here. Yeah, see, this is coming here, real polygons. It is giving you as a save file. That is the best part. Whatever you can create here, you can export it. So you can export it, and you can see this post bundle is only for, it's a manager to import data and export data. Nothing you can do more than this. So this is just an interface by which you can export your data and you can import your data. Is there any confusion to understand this? Okay. So you can also see whatever data you have created here, it should be called in your QGIS. So mostly corporate are doing the same thing. They have the database on their AWS or Azure. They store the data and they want to call it, because if they will give you the whole data, you will not able to handle that much data, because they are not working on one project or small project. They are working on very large data like Google Maps data. So they cannot give you like directly. So they store data on a cloud, and they give you the ID password of the database, and they tell you that go to this raster connection, not here, go to this. If they are using open source, so go to this here, Postgres. I also showed the same thing in the one class. So you just, it will be already connected, so I have to make one more connection new, because this is a different database. So I will give the name as GIS B2. Service host database, I have to give GIS. I think this is a database name B2. Yeah, and first we have to authenticate myself with the Postgres. Is my username. As I am a super user, you can also create your own users here. I will say to and test a connection. So connection is successful with this one, and then connection is done. I will click OK. So password, it is going to password, and we will say, so now we have two databases here, B2 also and GIS also. So we are working with the B2, and we will say connect. It was again asking me for our password authentication. Say okay. So it is coming public database, and you can see that all these things are coming here. Geo line strings. So these geo line strings are not projected. See, it is coming here, geometry. These are raster data. This is a geography data type. See, data type is also coming here. One raster data I can also upload, so I will show you how to upload data, and we can work on that also. So I want the dear polygons. I will click and I will say add it. So it will be added. So where is the data? I have to zoom to layer. Okay, so let's add some plugins here. Base map, I am adding the Google Maps. Some data is in Cairo here. I need to check the data first. Go to the attribute table. Let's, yeah, polygon 1, it is there, but it's showing a different expression. This is attribute table, correct? I want to zoom to the layers. So one data in the London, correct? Let me go to London. It's very small actually, so we cannot see the points. will be difficult to see it, like, but I will try to check it. Open attribute table. I think this data, yeah. But why it is coming in 3D? Okay, I have to put it upside. Yeah, now it is coming. Because this is a 3D layer, I think. Maybe it's 2D only, but it's showing 3D here. Some data we have. Some data in the Cairo also. Okay, no issues, like but we have added some data, correct? We tried to add some data. Now call that one more data set that we created a line. So I have to go to this add. I'm going to add the line, real line. Add it. Just close it. Yeah, this point I've created from Delhi to Kanyakumari. This is a very straight line. We are getting it, correct? We have created a lot of, so the length we have also tried to get it. So from here to here. Yeah, so you can call every feature here, whatever you are creating here. So this is how it works, the polygons. Now we have to care and look into the other things. Okay, now we are saying this one. So we are doing some query. Okay, so we are going to do some query based on our requirement. So first query, we are saying that these are the queries from polygons. This SQL query selects the ID and name column from the real polygon table. First one. Second query is like transforming the geometries from EPSG 3857 for accurate calculations. Okay, so we are going to change its projection system. So you know the projection system we have used is 4326 here. This one I want to change it. So for changing also we have one function called st transform, and st transform give the geometry, changes to geometry, geom give the table column name and changes to geometry, and give its projection system. Then I am trying to, we are using cast here. To cast is data type change. Okay, data type change. So because you are changing the data type, so you have to use a cast. Now we are looking into round. We are rounding it also, and these values we are getting, and I will using one more st area function to get the area and to get the perimeter. We are first transforming, changing the data type, and then letting it. Okay, so let me run this. I will check. So this is some of the queries we are doing, not only seeing the data but also looking into its detail, what is its area and perimeter. This we can say advanced query. Okay, in the advanced query what we are doing, we wanted the area. Okay, so we have a function called st area. In the st area we have to transform it, and we have to cast it, and we are rounding it. Okay, let me run this. It is working or not? Yeah, it is working. So for each polygon you can see your area, and you can see your perimeter of that polygon. You can also find the maximum and minimum of this. What is the maximum area, which polygon is having the maximum area, which polygon is having a minimum area, all those you can do. So queries basically corporate use these things to find us if they have some data. So like I am just showing you the functions which are available. So if you want to see the functions by yourself, how many functions they are giving, so you can see here you have some functions here. Yeah, this in the schema you will find the functions, and you can see all the functions which are available for you with st starting, underscore st, box 2d, box 3d, all these from a contains, drop geometry column, geography, geometry, all these functions are here. These are some raster functions. some PostGIS version, like to want to look into the what is the PostGIS version we are using with all the STs. These are the list of functions which you will use, which you can use for your work. So who will tell me the full form of SRID? What is the meaning of SRID?
Environmental Science Research Institute.
No, SRI, not SRI, SRID, 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 this one.
Spatial Reference ID.
A special reference identifier. Okay. So you can see that transform is here also, ST transform, ST transform. So you see which transform you have to use, geometry from projection to which projection, from projection text to projection text. That projection system we are using to transform here. See ST transform. We have the ST area also. So look into ST area. ST buffer you can use to create a buffer also, you can create. Yeah, ST area. See this ST area and give the geometry. We have so many ST area, ST area 2D, ST area geometry, ST area text, STS bind. So these three methods you have to look what are those. Okay, like you cannot cover all the methods, but based on your requirement of the client, based on your project details what they want, you can use these functions here. So you're not using any QGIS ArcGIS here. Basically you are doing all the functions which are available here only. So you can see one of the functions like casting. So this cast, if you someone ask what is this cast, so you can say that this cast is basically our data conversion. Okay, data conversion, we are doing data conversion from geography to geometry, then we are converting its area and all. So this is the type conversion, cast. If you also look what is cast in your what is cast clause in PostGIS, it will tell you that the cast is how to perform a conversion between two data types. For example, select cast 42 as float 8. So these are the data conversions. Okay, so do you know what is this float 8, int 64, int 32? What is this? Have you ever seen this float 8, int 64, int 32? See here it is int 4. Anyone, any idea?
Memory, is it a memory?
Yeah, it's basically the memory, but also you can see this as a uh, yeah, see look here. So I have look on this website what is mostly. You can see in 64, in 32 float. So just give me 1 second. This is not my website which I was looking for. Just give me 1 second. I'll just tell you the details of that. I had stored somewhere else. Yeah, this one I was talking about int int 32, int 64. So we have int 8. We start from int 8. So int 8 is ranging the number, like it's a standard number. So int 8 if you are giving, so it will only consist of 128 to 127. If you are giving int 16, so the int 16 is ranging between these values, minus to plus. Integer is minus to plus we can use. If you are using int 32, so it will consist of these data set. Okay, so these are the signed integers. Signed integer, we have two types of integers, signed integer and unsigned integer. Signed integer means sign plus minus sign, okay, and unsigned means without sign. This is called uint. So this is unsigned. Unsigned means you got it, with no sign. No sign means you will have no negative number. Sign is what? Plus sign and negative minus sign. So it is talking about u means unsigned. Unsigned means only positive. You have unsigned 16. Unsigned integer means with 0 to 65. 0 to negative numbers ranging from 0 to 65 and 535, 0 to 255, or it's maybe 0 to 535. If it is having an unsigned integer of 32, it is saying 0 to 65535, and it is saying 0 to 4294 up to this. If you are using unsigned integer 64, it is having from 0 to this value, this whole value. So we are using int 64, correct? So it is tending to these values. It cannot store after this value. If you give some values which are greater than this, it will be not going to store up to this, okay? So this is what I am trying to give you the idea, because most of time it will come, okay? You maybe use float 16, so you're using, so it's a 2 byte. It's also about your so we have talked about unsigned and unsigned integers, so we have the float also. Okay, so let's come to our queries. So we did one queries. So casting is changing a type of the data from geometry to geography, okay, or from changing from integer to float and all, because we have to use a round here. So for round we are converting it to a float to a integer. So that is why we have to first make it as a integer, and then we can round it. From float we are changing it to integer, and from integer we are getting it as numbers, okay. Now let's talk about some other queries. So we are done with our these things. For larger area also, okay, let's do this also, this query with a geography type. So we are also using here geometry as numeric, so it will be in kilometer. Okay, let's run this also. Let me check that it is working or not. Yeah, so if you look here, what we are doing here, so we are not changing the its geometry, we are not changing the data type. See, we are changing the data type, but we are not changing the projection. If you look here details and here details, there will be a change. Like, see, this is particularly like you have the GCS and projected. So this is giving you the projected. Sorry, this one 3855 is projected reference system, and this is not. So you look here, you take the snapshot of this data. So this is giving 3.15 for the polygon square area, okay. Now let's check with this, it will be increased at least 3.15, 5.49. See, it is increased. So whatever you can do, see, we have now, like we have the projection system of coordinate system, sorry, GCS and PCS. So this is your PCS, okay, with your PCS we can say it PCS, projected coordinate system. And you know that when you use a projected coordinate system and when you use a geographic coordinate system, so they do the deviations, they distort the shape, they distort the area, they distort the direction. So they are distorting, correct? When I'm giving this projection system, it is giving me my more area, correct? But when I'm using the same 4326 projection system, you can see this 5.49, which is the area of first polygon, it is decreased. See, it is decreased to 3.15 only. So these distortion will come when you are not very much have idea of your projection system. So this is with the projected coordinate system, and this is with your geographical coordinate system. So these things are also coming in your PostGIS. See how it is so much related with your GIS. This is called geographic coordinate system. So do you have any question to understand this, why we have done this? See, transformation we have not did here, correct? If you look into the both of your queries, in this query we have converted it, projection system we have changed to PCS, but here we are going with the default coordinate system, which is 4326, and then the consequences is that the area is decreased for our polygons. So this you have seen here only, correct? Is there any doubt to understand this?
Yes, sir.
Okay, so let's come to our, it's with this we have seen so many of our functions. You have seen ST transform, you have seen so now we are going to talk about some of our case studies. So I think case studies, should I start today? Okay, so tomorrow will you be available for the classes tomorrow also? Because I want to complete, because 20 minutes. Okay, one example we'll do today. Okay, this first fault line we will do, and Saturday one more class will be required here. So when you will be available on Monday?
Yes, sir.
Okay, Saturday not possible. Tomorrow? Okay, so let's first start today only. Okay, because we are going towards end, it will take only one or two more classes. So let's start the fault line case study. Okay, I think most of you know this fault line. So fault line is a area where two plates are joining. Okay, so we are going to work with the creating a table for fault line, and we will add some data here on this, and we will do some analysis. Okay, we will do some queries there. So let's create a table for our fault line. Okay, so I'm going to create a table. So I will use a new open file, edit. Okay, I'm not going to save it. Okay, so you know all those things, correct? So just open a new query tool here. I will add a new query tool here. Okay, and I will start working on here. So I'm going to create a table for our storing the fault lines. Okay, locations. So you can see that I am using 4326, that will be supported by our leaflet. I am using as ID, name, and geometry. And geometry I am giving geometry, and I am saying it as a line string because every fault line is a line, not a polygon. So I am creating it. So it is created. Now we have to add some data inside this. So data we can add using our insert into, give the table name, give the columns, and give the values for those columns. So first column is a name, and this is San Andreas fault, which is the largest fault, and I'm going to create with the help of line string and giving two location, latitude and longitude, in a pair. So this is a pair separated by comma, and a second pair, and this is my projection system. They want projection system also. So we have 1 2 3 4 5 6 7 8 9 data we are going to insert here. Okay, so let's add the data, insert our data in our database, in the database of our table. What is the table name here? Fault lines. So when you add, it is saying inserted 0. Now I want to look all these things. Okay, so we will be using the select star from fault lines, from the fault lines, and I will close my statement with the semicolon, and you click on this execute button. Here you can see all your lines are coming here. This is a hexadecimal codes. Okay, if you want to see, so you have to use st as text here. That we can also check. Now I want to look into the geometry. I will click here. Okay, so by mistake I selected only one, so it is giving me only one. So okay, let's check for one only. So this is my first fault line here, San Andreas fault, correct? Second one, if you want to look second one, I will not select the first one, only second one I want. So click here, and you will get a second fault line here, but I want all at once. I'm going to select all the fault lines and we can check it. See, this is one fault line, this is one fault line coming here. If you want to export it also, if you don't want to export save file, you can also see from here, it will be updated here. See, go to the this one, add data, and we want to add from here. Still it's not updated, correct, in the fault line. So first we need to connect, okay, and connection, yeah, fault line are coming here, correct. See, fault lines are coming, just add it, close. So fault line, real polygons, save, yeah, it is coming. See, this is my first fault line. The problem is with the symbology. I have to change the symbology of this. Going to properties, symbology, I want the width some little more. I want width 5, right? Yeah, oh, this little high. 2 will also work here. Okay, so you can see this fault line is coming, correct. Some fault line are here. This is my 2 fault lines. A directive we are creating, and we can look from here also. So you can also export from here. Right click and go to export feature as. You can export from here also. You can export from your PostGIS also. So this is my you can also do analysis here if you want, correct. So I am going to do some analysis here, okay, and let's see how we can do. So I want to read it as a text, not as a hexadecimal, but when you look in which or as a text, it will be, the geometry will be not there. Okay, we are interested to see as a text, so we are using st_text function from the fault line and just execute the script. You will be getting the lines, the locations, okay. So we are not also interested in this, we have done these a lot. So now we are interested in the queries, what we can do more. So for more, we can see, you can find some fault lines nearby Nairobi, Kenya. So for that we will be using some methods here which we told. I am calling the methods here and I will explain it. Advanced queries, it's come under your advanced queries. Okay, so you can see that I wanted to see the name, okay, only name I want to see, and I'm saying that from, give me the from your fault line table, and I'm using a clause where, and I'm using one method, one function, that is st distance within. So I'm using this one, say I'm just using this one to get whatever fault line is near to this with a distance of 100 km near to this point, okay. So I am using this st geometry from text. I will be giving this point, and I'm saying that if some points, if some of the locations or some of the fault lines are near this one with a distance of 100 km, if someone fault is coming with a distance of 100 km near to this point, just show me, and just give is projection system, okay. So whatever the your points will be near to 100 km of this point, it will be showing. So this point, so let's run this command, this query, and check. You can see that all these points, 6 our data are near to this 100 km of this zone. So let's me just change it to 10 km and selecting it and doing the query. You can see only 2 are here with near to this point. We have only 2. So this point will be where? Can we locate this in QGIS? Do you know how to locate this point here? In ArcGIS we have one tool, but QGIS I don't know. Okay, I will go with this coordinate system. So where is it? 36 minus 1. This is longitude, 36 and minus 1. 36 and minus 1, 36. This is a 36, correct, and this is minus 1. I am going 36 and minus 1, 36 minus 1, this one near to this location, 36 and minus 1. Is this correct? This is a latitude, 36 degree latitude, 36. Okay, I will do minus 36 and 1. -1 and 36. Okay, these two locations, correct? This is a -1, 36. So these 2 points are around 10 kilometer. If you look into 100 kilometer zone, so 100 kilometer, it is coming some 7-8 data. Like this is, it will be more, but I think this is in degrees. Okay, this is in the degrees, not in the your kilometers. But here we are using here, this will be not in your distance of kilometer. Okay, so this is your not at your kilometer, this will be in the degrees, within the 10 degrees. Okay, if you write here 1 degree, also let's see in the 1 degree what are the features are coming. Okay, so select, I have not used. So in the 1 degree only one data is there. In 1 degree means 111 kilometer. Okay, so if you write 10 degrees, so in the 10 degrees so many data are here, or okay 2, and with 15 degree or 20 degree only 2. So in 50 degree, yeah, 5 are coming in 50 degree. And if you go to 60 degree, 60 degree up to 60 degree down, 5. So we have up to 90 degree, correct? So 90 degree, 6 is coming. It will be 180 degree, 180, all will be coming in 180 degrees. Yeah, all points are coming in 180 degree, correct? So this way we have seen to find some data which is near to this point and having a distance of in degrees. Let's talk with the other queries. We have a lot of queries we have, so we can create we are going to find a length. Okay, finding the length of each of our fault line. Okay, so we will say select the name and use a st-length simple method, and geometry you have to do, and 1000 kilometer to divide it. So this will be also giving a wrong length because this will be in the degrees, and degrees to you have to use 111 to get in kilometers. Let's send this. So you are getting the distance in kilometers. Mm. 1200, 300, 4000, East African, 3000, 1800, 23 mid-Atlantic regions, so 29,000 kilometers. Yeah, so this is how you can get the length. So today I will keep up to only this one. Okay, and other things like other queries I will do in the next class. Okay, do you any question here?
Sir, what is this dividing it in school one?
Dividing it basically, basically we have in the decimal degrees, correct? It's a projection system is in your decimal degrees. So to decimal degrees we are converting here. See this one. We are going to calculate the length. So length will be in a kilometer. So
Sir, got
change
it.
your degree to your kilometer. That is your, we are dividing or we are multiplying. So you have to look, we have to multiply or you have to divide here. Okay, to convert it to length and all. This is what.